I want to take a moment to talk to you guys about finding the area between two curves with respect to y instead of x. So doing our integration with respect to y instead of x. So this is one of the problems out of the book. Okay, and so you can go ahead and you can look in the text. If we just move over here. Okay, this is the problem that I'm going to look at. And there's a solution available here. So we'll go through that in just a minute. But let me explain what the problem is. They want you to find this blue area right here. Now if we just take the top guy minus the bottom guy, we're going to end up with extra area down here that we don't want. So instead what we'll do is we'll take our sections horizontally instead of putting our rectangles in there vertically. I'm going to do it both ways so that you can see that the answers are the same. So what I need to do is let me just draw the curve back out over here. Okay, so this right here is y is equal to x to the 2/3. And our other function, the one in black, I'm going to draw it here in orange, hits over here at 4, comes up like this, and would extend down in this direction if we kept it going. And of course we are interested in this area right in here. Okay. Now this orange line is given to us by this equation, y is equal to x minus 4. And what the author did here is they solved for x for both these. Because what we're going to do is we're going to integrate, okay, with respect to y. So we're going to come left and right here with our rectangles. So what do you need to do that? Well, you need each of these relations to be written instead of y is equal to, we need to isolate x. So this guy right here is going to become x is equal to y minus 4 when I move this piece, plus 4, when I move this piece over. This guy here in the purple is going to be x is equal to y to the 3/2. Now we can check with these last two, this guy right here and this guy right here, we can check to see if these two are actually the same as these two. So what I'll do is I'll just grab Desmos, and so let's go ahead and put all those in. I'm just going to retype them. Okay, so the first one was y is equal to x minus 4. That's the graph that we just took a look at. Now if I solve for y and I have x is equal to y plus 4, what I want you to notice is that if I toggle on and off, let's make it a little darker here. If I toggle on and off, those lines are the same. Okay, so they represent the same thing. The other one, when I solved, I got for y is equal to x to the 2/3. Oops, sorry about that. Okay, so we had y is equal to x raised to the 2/3. We get this function. And then when we solve for x, we got x is equal to y raised to the 3/2. Now watch what's going to happen. So this new solution, so we already showed that the first one that it worked. But for the second one, notice that the two graphs are not quite the same. And the reason for that is in this second case, y, the value, the x value here, okay, can't be negative. So our x values, it can't take on negative values because there's no way to make this expression negative. However, up here, x can take on negative values because we're squaring and then taking the cube root. That's not an issue here, and here's why. The purple function and the orange function look exactly like one another over the interval that we're trying to find. So since they look like each other, and they give the same results out, we can use one in replacement for the other. But I want you to note that these two are not exactly the same. So this first guy gives me some line over here, and the second guy, over here, and the second guy doesn't. But it's all right in this case, like I said, because it's over the positive x's, so we're good there. Now what we need to do is we need to take the y that's further to the right, so the function is further to the right, and subtract off the function that is to the left when we do our integration. Okay, so we'll take the guy that's further to the right, okay, which is y plus 4. And then we're going to have to subtract off the guy on the left side, which is y to the 3/2. My y's don't look the same. Let's make them look the same. There we go. So dy. Now we just need our boundaries, but we're talking in terms of y, so we've got to look. Our boundaries for our integration are from here to here because they're the y values. So we want to go from 0 to something up top here. So we need to figure out where these two guys intersect. So 0 to something. Now there's a couple ways you can do this. You can do it out algebraically, or you could use some graphing software. Okay, I'll let you figure out how you want to do it. But this is over a length of 8, and this is up at a height of 4. So we need to integrate between 0 and 4, not between 0 and 8. So remember, we're not integrating over this axis. We're not putting the rectangles over this axis. We're putting them over this axis. So oops, I wrote an 8 and I said 4. So from 0 to 4. Okay, now the rest of it is just mechanical. So we just need to find an antiderivative for the inside. So what I'm going to do is say this is 0 to 4 of y plus 4 minus y to the 3/2 dy. And that's equal to the following: y squared over 2 plus 4y minus 2y to the 5/2 over 5. Think about why this is the antiderivative for this. We want to evaluate that between 0 and 4. Okay, so let's go ahead and work that guy out. So when we plug in 4, we get 4 squared over 2 plus 4 times 4 minus 2 times 4 to the 5/2 over 5 minus, when you plug in 0 for all of these y's, you get 0 out. So that's going to be 16 over 2 plus 16 minus 2 times. Now, do the root first. Okay, so the square root of 4 is 2. 2 to the 5th is 32. It's easier if you do it that way than the other way, over 5. So this is going to be 16 over 2, which is 8. Let me just replace that in there with 8. Plus 16 minus, now this is going to be 64 fifths. So 8 plus 16 is 24 minus 64 fifths. And so this is going to be 120 over 5 minus 64 over 5. And so 120 minus 64 gives us 56 over 5. And that gives us, I believe, 11.2. So the area, this blue area, is 11.2, okay, units squared. Okay, that's what we've got. Now we don't have to do it over the y-axis for this particular one. We can still do it over the x-axis, and so I want to show you that as well. So let me go down a page here for you. The thing is, you're just going to want to split it up, and you can do it a couple different ways. I'll do it one way, and you can think about how you would do it on your own. So this was y is equal to x raised to the 2/3, and then we had another line here, and I'll do it in green. And this one was y is equal to x minus 4. And again, we want to find this area right in there. So what we can do, a couple different things. What we can do is we can split this here and find this area on the left. I'll call it, let me erase this. Oh, I didn't want to erase all that. Let's drop back in. This area over here we'll call region 1, and this area over here we'll call region 2. So if we want to find region 1, well, it has nothing to do with the green line. It only has to do with the purple line. So region 1 is equal to the integral of, now this goes from 0 to 4. We're going to need this guy in a minute, and this guy is 8. So we want to find region 1, we go from 0 to 4 of this purple guy. Okay. I want to make sure that I wrote that down right. X, yeah, x to the 2/3. Okay, good. Dx, of course, because it's with respect to the x-axis. Now to get region 2 in here, okay, what we're going to do is, we've got a couple ways to do this. We can take the top equation and subtract off the bottom equation, so I'm going to start with that. So that would be the integral from 4 to 8 of the purple line minus the green line dx. So integrate from from 4 to 8 of x to the 2/3 minus x plus 4 dx. Okay. So now we've got these two separate ones. We'll just add them together when we get to the end. Okay. But what I want you to notice here is I can move this guy in. So this is kind of cool to look at. I can move this guy in from 4 to 8 of x to the 2/3 like that. And then if I want to, I can pull the negative sign back out of this right here. And again, we have from 4 to 8 of x minus 4. Of course, these are both dx. Well, geometrically, what does this say? This says, if I put the whole thing together, okay, it's kind of cool. If I put region 1 plus region 2 together, and region 2 is both of these, I get the following. I get the integral from 0 to 4 of x to the 2/3 dx plus the integral from 4 to 8 of x to the 2/3 dx minus the integral from 4 to 8 of x minus 4 dx. Now notice that these two guys are the same, and so I can combine those to be the following: 0 to 8 x to the 2/3 dx minus 4 to 8 x minus 4 dx. So you don't have to do this, but look what this gives us. This says take the area from 0 to 8 underneath the purple curve. So it says, let me get rid of this. It says to find that area in between the curves, take the area underneath the purple guy from 0 to 8 and subtract off the area underneath the green guy from 4 to 8. So if you take the purple, all the purple, okay, that's this whole section, subtract off the green, guess what you get? You get the area on the inside. So just this little manipulation gave me the same exact thing. So you could have started right here instead of going this route up here. Okay, it depends. You can really do it whichever way you want to do it. Okay, so the rest of it is just computation. So I'm going to let you go ahead and work through this and show that this gives us that value of 56 divided by 5.